Good day, viewers. You are welcome back to Tindanious Math and Science tutorials. We are still considering complex numbers, but today is the last part of complex analysis or complex numbers. Okay, so let's consider a question on the board to end everything. So solve the equation below. You have z to the power 4 minus 1 equals I root 3. Viewers, we already know that this is not in the standard form. So we have to write this in the standard form. Why are we doing so? We are doing so because you already know that mathematically, complex numbers can be expressed as what? We denoting the real part of the complex number and the imaginary part of the complex number. So we have to do justice over here. So we have z to the power 4, which is equal to, you transpose this, you have positive 1, then I have plus I root what? Root 3. I'm making z the subject over here. So what do I do? So I have z to the power 4. You multiply it by the reciprocal of the number in order to discard the number over the right, which is equal to whatever you do to the left-hand side, you do same to the right-hand side. I multiply by 1 to the power over 4, you do same. This cancels this. So this is the same as z equals, that's 1 plus, this is the same as root 3, then I, all raised to the power 1 over 4. This is also the same as 1 plus root 3i, that's to the 4th root of this. As simple as that. So if that is the case, let's look for our r, the modulus, right? Our r or the modulus is given by, you square the real part, which is my 1 squared, then you square the imaginary part. So I have what? Root what? 3, all squared. By the help of the calculator, this is giving us what? 2. Let's look for the angle. You know that angle theta is given by tan inverse of x, that's y over my x, the second one over the first one. So I have root 3, this over 1. So this is the same that as theta is equal to tan inverse of root what? Root 3. So therefore, theta is equal to 60 degrees. So you know that in radians, theta is equal to, that's 1 over 3 pi, which is the same as what? Pi over 3. As simple as that. So what do we know now? We know theta, right? We know r. But is this the true angle? Is this the reference angle? Is this the actual angle? Is this the argument? Is this the amplitude? So unless we do that, or we can test for it using what? Using Argand diagram. So Argand diagram will let us know that are we supposed to use this angle or not. Okay. So I have my complex plane over here. So here I have, this is my x. Consider this to be your x, and this is your y axis, which is your I, your imaginary axis. So this is your I and this is your x. Let's look out for the point of intersection. Okay. So I have 1 on the x, I have 1. So this x, I have 1 over here. And the I axis, I have root 3. So here, I axis, I have, let's assume root 3 is over here. You trace this over here, you trace this over here. You are looking for the point of intersection. So having done that, then you draw a straight line to pass through the intersection, right? But viewers, this is not really needed over here. Why? Because so far as it belongs to the first quadrant, then obviously theta is always equal to alpha. So far as it's in the first quadrant, whatever angle you have in question is just the same as alpha over here. Or is the same as the true angle, is the same as what? the reference angle. As simple as that. Unlike the previous question we had solved, and we saw that the angle was somewhere here. So we had to what? We had to modify or adjust what? The angle using the Argand diagram. So let us not worry ourselves. Since it's in the first quadrant, this angle is the true angle. So therefore, I can say that theta here, I have it to be 1/3 pi. I know n is equal to 4 because first, second, third, and the fourth root, that denotes your n, the highest number of roots. Then, what do I know? I know r. My r equals 2. What else? That's all, right? But we know that k assumes or tell us about what? About the number of distinct roots, starting from 0, 1, 2, then up to 3. Why up to 3? This 0 denotes your first root, second root, third root, and the fourth root. Therefore, we will end over here. So I'm looking for my first root, which is this. So when k is equal to 0, because 0 denotes the first number, right? So this is the first root of the complex number. So therefore, z at 1, that's the first root, is given by r to the power 1/n. So what is my r? R is 2 to the power 1/n. What is my n? My n is 4 over here. Then multiplying cos. Then I have theta. What is my theta? Theta in radian. We have it to be what? Pi on 3. Then plus 2 pi times k. What is k? K is equal to 0 from here. Then all over n. What is my n? My n here is equal to what? My 4. Whatever you have over here, you copy and you paste everything. So I have pi over 3, then plus 0, right? So 2 pi times 0 all over 4. As simple as that. So my first root is given by 2 raised to the power 1/4. Then I have cos. So the whole of this should give me 0, right? I have pi on 3 divided by 4 over here. Then plus I sine, you copy and you paste because everything here goes to 0. So I have pi over my 3, then all over what? Over this 4. So basic algebra will tell this. You have cos, then multiply this, okay? 4 times 3 gives what? 12, right? So I have pi, then all over what? All over 12. Then plus I sine, I have what? Pi, all over 3, 4, 12. As simple as that. I'm done. This is the first root. So if the question had said the first root of the equation, we'll end here. So we have the second root, right? So considering the second root, k equals 1. Because first root, second root, right? So we just do substitution over here, just copy and paste everything. So I have z at 2, z2 is equal to 2 raised to the power 1/4. Multiplying, I have cos. What do I have? Pi over 3, right? So pi on 3. Then plus 2 pi times the k. Here k was 0, but here k equal to 1. So times by 1. Then all over 4. Then I have plus I sine, copy and paste everything. So I have pi over 3 plus 2 pi times 1 is simply 2 pi. Then divided by 4. So we have z2 is equal to 2 to the power 1/4. You have cos. When you evaluate this, you should get 7 pi over 3 and all over 4 this way. Okay, by the help of the calculator. Then plus I sine, they have 7 pi over 3 over 4 this way. So my final answer should give me 2 to the power 1/4 multiplying cos, then 4 times 3 is 12. So I have 7 pi over 12. Then plus I sine 7 pi over 12. As simple as that.
Let us consider that's the third root of the equation. Okay, so considering the third root, right? So considering the third root, say k is equal to 2, right? Why 2? Because here is first root, second root, third root. So therefore you can say that copy of this again, you have z2 is equal to 2 is about 1 over 4. What's that called? We have for theta, right? Theta is pi over 3 plus 2 pi times our k. But k here is equal to what? 2. Then all over n is equal to what? 4. Then plus I sine, copy and paste the same thing. So I have pi over 3 plus 2 to 4. So 4 pi all over 4 this way. As simple as that. So z at 2 is equal to that's 2 to the power 1 over 4. Then I have cos. So this will give me 13 pi over 3 all over 4 this way plus I sine, you compute this using the calculator, you should get 13 pi over 3 all over 4. This is basic algebra. So Z3 should give me 2 to the power 1 over 4. I have cos, then I have 4 times 3 is 12, so I have 13 pi over 12. Then plus I sine, that's 13 pi over 12. As simple as that. And the last question to end the tutorial is when k is equal to 3, that means what? The fourth root. So I have z at 4, that's the fourth root, is given by 2 to the power 1 over 4. Half multiplying cos, the one we have pi over 3, right? So pi over 3 plus 2 pi times my k. My k is what? It's 3, right? Good. So 3. Then all over my n is 4. Then plus copy, then paste everything. So we have pi on 3 plus 3 times 2, 6. So 6 pi. Then all over 4. So this is the same as 2 to the power 1 over 4. Then we have cos 19 pi, right? 19 pi over 3. Then all over 4 this way. Then we have plus using simple algebra. You compute this. You have 19 on pi over 3 divided by 4. So the last step is 2 to the power 1 over 4. I have cos, you have 19 pi over 4 times 3 is 12. Then plus I, then sine, you have 19 pi divided by 12. As simple as that. Viewers, this is the end of the tutorials. Viewers, in fact, we've covered extensively on complex numbers. It's complex numbers, but it's not complex. It's very, very simple. So far as Tindanious Math and Science YouTube channel is concerned, in fact, consider difficult stuff simple, right? So viewers, that's the end of the tutorials. But note this, if you have this question, we find the
fourth root of the equation. Viewers, you don't have to struggle doing this. Okay, so because you are looking for the fourth root, you know that k should begin from what? From 3. Okay, so for the fourth root, when you work it straight away using this, you should get the answer.
You don't need to go through first, second, third. I'll meet you next time for another interesting updates and topics. I love you.